Welcome to another deep dive. Today, we're going to be looking into Claude Shannon.
Oh, yeah.
You ever heard of him?
Not really.
Yeah, most people haven't.
Okay.
But we are surrounded by his work every single day.
Hmm.
And we've got an article here all about him.
Interesting.
And it,
Yeah, and so what's the plan?
yeah, so I think our mission is to really try to understand how this guy, who most of us have never even heard of,
Right.
how he shaped the entire digital world, like all the technology we depend on.
Yeah, how did he do that?
That's what we're going to try to figure out.
Okay.
And also, get a handle on some of these key concepts that he pioneered
Okay.
that we all kind of take for granted now.
Yeah.
Like, the whole idea of a bit.
Oh, yes.
We'll talk about that, I think.
Okay.
And then also, like, this crazy thing I read about where in Boolean algebra,
Right.
1 + 1 = 1.
Yeah, what is that about?
Right. I don't know. We'll have to figure that out.
It's not regular math.
No, definitely not a regular math. And then this idea of information entropy,
Okay.
it has something to do with, like, coin flips.
Oh, okay.
Which I don't really understand, but that's why you're here.
Well, we'll figure it out.
Okay, good. So who was Claude Shannon? What was he like as a person?
Well, he was this brilliant mind,
Okay.
but kind of a quirky genius.
Okay.
Not a household name.
Yeah, we talked about that.
Right, like a Bill Gates or Steve Jobs.
Right.
But arguably just as important.
Yeah.
When you think about his impact on our lives.
Okay.
The article starts off talking about his master's thesis.
Okay.
He wrote this thesis when he was only 21.
21.
At MIT.
Wow.
And this thesis was groundbreaking. It kind of laid the foundation for digital computing as we know it.
Really? Like he was that young and already changing the world?
Yeah, pretty much.
So what was so special about this thesis?
Well, he dove deep into this system called Boolean algebra.
Okay.
And he figured out how to apply it to electrical circuits.
Boolean algebra. That sounds a little intimidating.
It's not as bad as it sounds.
Okay, good.
It's actually a really elegant system of logic.
Okay.
And the basic idea is that everything boils down to true or false, represented by 1 and 0.
1 and 0, okay.
And Shannon saw how the system could be perfectly mirrored by electrical circuits.
Okay, I'm listening.
You know those switches that are either on or off?
So like a light switch?
Exactly.
Yeah.
It's either on or off.
Right.
There's no in between. And that simple concept, that's the heart of digital technology. A closed circuit represents true or 1.
Okay.
An open circuit represents false or 0.
Right, okay, so far so good.
You got these simple switches,
Yeah.
but Shannon realized that by combining them in different ways, you could create much more complex logic circuits.
Okay, so how do you go from like a light switch to something like a computer? That seems like a big leap.
Well, these circuits could be used to perform calculations,
Okay.
store information, and ultimately make decisions.
Really? So he saw how something as simple as a light switch could be the building block for these incredibly complex systems.
Exactly. And it wasn't just theoretical for him.
Okay.
Shannon was also a tinkerer,
Oh, really?
kind of an inventor. He loved building things,
Like what?
like juggling machines.
A juggling machine?
Yeah, he built a mechanical mouse that could solve mazes.
Wow. Okay, so he was a hands-on kind of genius.
Yeah, he was able to see the practical applications of his theories.
That's pretty amazing.
So you got this deep understanding of logic and information.
Yeah.
Combined with this kind of hands-on inventor spirit.
Yeah, okay.
But how does this all relate to communication?
Right. That's what he's really known for, right?
Exactly.
So how did he make that connection?
That's where his concept of information entropy comes in.
Right. This is where I get lost, I think.
Well, it's a little bit tricky,
Okay.
but it's really important
Sure.
for understanding his impact.
Okay, so give it to me.
Okay, so imagine you're flipping a coin.
Okay.
If it's a fair coin,
Mm-hmm.
you have no idea if it'll land on heads or tails.
Right.
There's a lot of uncertainty.
Okay.
But what if it was a trick coin?
A trick coin.
Yeah, with 2 heads.
Okay.
Then there's no uncertainty at all.
Yeah, it's going to land on heads.
Exactly.
Okay.
Shannon realized that uncertainty is directly linked to information.
Oh, okay.
The more uncertain you are about something,
Yeah.
the more information you gain when you learn the outcome.
So if I know for sure what's going to happen,
Yeah,
then it's not really new information.
right. It's like a message that's super predictable,
Okay.
contains no surprises,
Yep.
has low information content.
Because you already know what it's going to say, basically.
Exactly.
I get it.
And Shannon applied this idea to communication itself.
Okay.
He saw that information, at its core, is about reducing uncertainty.
Right.
He wanted to find the most efficient way to transmit a message.
Okay.
getting rid of any unnecessary redundancy.
So it's like packing a suitcase.
Okay.
You want to fit as much as you can in the smallest space.
That's a great analogy.
Okay, good.
And this led him to develop information theory.
Information theory. Okay.
This whole field of study dedicated to understanding
Right.
how information is created,
Yeah.
transmitted, and received.
Okay, so let me see if I've got this straight.
Yeah.
We've got this brilliant guy who loves to tinker and build things.
Yeah.
He figures out that information is all about reducing uncertainty.
Exactly.
And he sees how basic logic can be represented by electrical circuits.
Right.
And he's obsessed with transmitting information as efficiently as possible.
It's all connected.
Yeah, wow, okay.
So where do we go from here?
I don't know, you tell me.
Well, this is where Shannon takes another giant leap forward.
Okay.
And this leads us to the concept of the bit.
Wait, like megabytes and gigabytes?
The very same.
Wow, okay.
Shannon realized that those binary choices,
The true or false, the 1 or 0.
exactly, could be represented by a single unit of information.
Okay,
And he coined the term bit, short for binary digit,
okay.
to represent this fundamental unit.
So every time we talk about digital data,
Yes.
whether it's sending a text or downloading a boofy,
It's all bits.
we're essentially speaking in Shannon's language.
You got it.
Yeah.
Those ones and zeros,
yeah.
those bits
But the bits,
are the foundation of the entire digital world.
that's incredible.
And it all goes back to his work on Boolean algebra, information entropy,
Right.
and his desire to make communication as efficient as possible.
I'm starting to see why he's considered such a foundational figure, even if most people don't know his name.
Yeah, it's like he's the wizard behind the curtain making all the magic happen.
Okay, so that's amazing.
But the article doesn't stop there.
Oh, there's more.
Oh, yeah.
Okay, what else did he do?
Well, he also did some fascinating work on something called the Shannon limit.
The Shannon limit. Okay, what's that?
Well, it's a bit more technical, but basically Shannon figured out that there's a theoretical limit to how much information you can send through a communication channel.
So like a speed limit for information.
Exactly. You can't just cram an unlimited amount of data through a wire or a radio wave.
Right, that makes sense.
There's a point where you start losing information
Yeah.
due to noise and interference.
Okay,
And Shannon was able to calculate this limit.
so this is important.
Huge implications for how we design and use communication systems today.
Wow.
Even though we might not realize it,
Yeah,
his work is affecting our everyday lives in countless ways.
it's kind of mind-blowing when you think about it.
It is.
But the article also mentioned something about Shannon's later years,
Oh, okay.
particularly his struggle with Alzheimer's disease.
Oh, wow. That's so sad to think about.
It is.
Especially given that his life's work was all about information and knowledge.
Right.
It must have been incredibly difficult for him and his family. It's a poignant reminder that even the most brilliant minds are not immune to the fragility of human existence.
Yeah, that's heavy.
It is.
I feel like we've only just scratched the surface here. There's so much more to explore.
Absolutely.
Especially the practical implications of his work in the digital age.
Definitely.
But for now, I think I need a break to let all of this sink in.
Yeah, good idea.
We'll pick up our conversation in the next part of our deep dive into the world of Claude Shannon.
Looking forward to it.
Okay, so before the break, we were talking about the Shannon limit.
Yeah, that's speed limit for information.
Right, so can you give me like a real-world example of that?
Sure. Think about like your Wi-Fi connection.
Yeah.
You know how it gets slow sometimes?
Oh, yeah, especially when a lot of people are using it.
Exactly.
Yeah, super frustrating.
Well, that's the Shannon limit in action.
Really?
Yeah, your Wi-Fi router can only send and receive a certain amount of data per second
Okay.
without errors.
Mm-hmm.
If you try to push too much data through,
Yeah.
like when everyone's streaming movies at the same time,
Yeah, everybody's on Netflix.
the signal gets congested
Right.
and things slow down.
It's like rush hour.
Kind of, yeah, like trying to fit too many cars on a highway.
Right. Everything gets backed up.
Exactly.
Yes.
And Shannon's work helped engineers understand this fundamental limit,
Yeah.
so they could design better communication systems
Right.
that get as close to that limit as possible
Right.
without sacrificing reliability.
Okay, that's cool. So the article also mentioned how Shannon applied these ideas to language itself.
Oh, yeah.
Can you explain that?
Yeah, so Shannon was curious about how much information is actually contained in language.
Okay.
He did some calculations
Oh, wow.
to figure out how many bits you would need, on
Right.
average,
Yeah.
to represent a single letter.
Like a letter of the alphabet.
Yeah, of the English alphabet.
Okay.
So like a digital code for each letter.
Yeah, like a secret code?
Yeah, kind
Right.
of. He found that if letters were randomly distributed,
Okay.
you'd need about 4.7 bits per letter.
4.7. Oh,
But of course, letters in a language, they're
Yeah.
not random.
right. We have like patterns and rules and stuff.
Exactly. That's a key insight.
Oh, okay.
Shannon realized that the structure of language
Yeah.
actually helps us compress information.
Hmm.
We don't need to treat each letter as a completely independent unit.
Okay.
For example, if you see the letter Q,
Yeah.
you can be pretty sure the next letter is going to be U.
Right. Okay, that makes sense.
So our brains are already doing a kind of information compression
Really?
when we speak and write.
Wow.
We're using those patterns and rules of language to convey meaning with fewer bits of information
Okay.
than we would need if every letter was totally random.
That's pretty mind-blowing.
It is, and Shannon even speculated about the possibility
Oh,
of
wow.
creating entirely new
New
languages
languages.
that were optimized for even more efficient communication.
So like a language designed just for transmitting information.
Yeah, with the fewest bits possible.
That sounds like science fiction.
It does, doesn't
Yeah.
it? But it speaks to Shannon's incredible imagination
Yeah.
and his desire to push the boundaries.
Okay.
He wasn't content with simply understanding how things worked.
Right.
He wanted to explore, like, what could be done.
The possibilities.
Yeah, what's
He
possible.
was a visionary.
He was.
Okay, so we've covered a lot here.
We have.
Boolean algebra, the Shannon limit, information theory, the structure of language.
Yeah, it's all connected.
What ties it all together? What's like the main theme of his work?
Well, I think the key takeaway is that
Okay.
Shannon saw information as this fundamental concept.
Okay.
Something that could be quantified
Mm-hmm.
and studied scientifically.
Mm-hmm.
He gave us the tools to understand how information is created,
Yeah.
transmitted, and received.
Regardless of the medium.
Exactly.
And that understanding has had a huge impact,
Yeah, it really has.
even if most people don't realize it.
Absolutely. His work laid the foundation for the digital age.
And his insights still shape how we communicate today.
Yeah, how we interact with the world around us.
But as we talked about before,
yeah,
the information age has its downsides too.
definitely.
The article talked about Shannon's struggle with Alzheimer's.
Right. Really sad.
Yeah, and kind of ironic given his work on informations and memory.
Yeah, it is. It's a reminder that even with all our technological advancements, we still face these profound human challenges.
Right.
And it raises some questions
Okay.
about the nature of information
Okay.
in a world that's just flooded with data.
Right, we're bombarded with information constantly.
We are.
But does that make us more knowledgeable?
That's the question, isn't it?
Yeah, are we actually wiser?
It's a crucial question.
Yeah.
And it's one that Shannon himself grappled with.
Oh, really?
He dreamed of faster, more efficient communication.
Yeah.
But did he foresee the potential for information overload?
Right.
And the misinformation that we see today?
That's a good question. I mean, on the one hand, it's amazing that we have access to so much information.
Yeah.
But it's so easy to get lost in all the noise
Yeah.
and like lose sight of what's really important.
And it's not just the quantity, it's the quality too.
Oh, right.
You know, we're constantly exposed to misinformation, propaganda,
Mhm.
biased perspectives.
It's hard to know what to trust.
It is more important than ever to be critical thinkers, to
Right.
discern truth from falsehood.
I wonder what Shannon would think of all this.
I don't know, it's a good question.
You know, he was all about efficiency,
Yeah.
but would he be excited about the possibilities
Mm-hmm.
or concerned about the potential for misuse?
We can't really answer that.
Yeah.
But it's definitely worth thinking about.
It is.
You know, he laid the groundwork for the information age,
Yeah.
but it's up to us to decide how we use the tools he gave us.
Okay, so this is heavy stuff.
It is.
We've gone from light switches and coin flips
Right.
to the Shannon limit,
Mm-hmm.
the structure of language,
Yeah.
the challenges of the information age.
That's a lot.
I need a minute to process all this.
I understand it's a lot to absorb,
It is.
but that's the beauty of a deep dive like this.
Okay.
It challenges us to think about familiar concepts
Yeah.
in new ways.
Right.
And to grapple with the complexities of the world.
Yeah, the world around us.
Exactly. But we are about out of time.
I suppose we are. Let's wrap things up after a short break. Okay, so we've spent this whole deep dive exploring the world of Claude Shannon.
Yeah, it's incredible how much his work has shaped our digital lives.
And I think it's safe to say that most people have no idea.
Yeah, he's a true hidden genius.
So as we wrap things up, let's try to distill some key takeaways for our listeners. What are the most important things they should remember about Claude Shannon?
I think the biggest takeaway is that he gave us a whole new way to understand information itself.
Okay, how so?
Well, before Shannon, information was just kind of like, well, facts and stuff, right?
Yeah, that's how I would have thought about it, I guess.
But Shannon showed us that it's not just about the facts themselves, it's about reducing uncertainty.
Oh, right. Like that coin flip example.
Exactly. A trick coin with two heads gives us zero information because we already know the outcome. But a fair coin toss, that's where we gain information because the outcome was uncertain.
Yeah, that makes sense. And Shannon applied that to communication in general, right?
Exactly. He showed us how to measure information, compress it so it's more efficient, and how to transmit it reliably so it doesn't get garbled up along the way.
And the thing is, he wasn't just some guy theorizing in an ivory tower.
Oh, no, not at all.
He actually built things, right? Like that juggling machine and the maze-solving mouse.
Absolutely. He was a hands-on genius who could see the practical applications of his ideas.
And that led directly to, well, everything we're using to have this conversation right now.
Yeah, his work on Boolean algebra and how to represent it with electrical circuits, that's the foundation of modern computing. Without that, we wouldn't have smartphones, laptops, the internet, any of it.
It's crazy when you think about it. Something as complex as a smartphone boils down to a bunch of on-off switches.
And it's not just the devices, it's the whole digital infrastructure that connects us all. The internet, wireless networks, data centers, all of it relies on Shannon's principles of information theory.
It's a legacy that's pretty hard to overstate. But we also talked about the darker side of all this, right?
Yeah, the information age isn't all sunshine and roses.
The article's account of Shannon's Alzheimer's was really heartbreaking.
It is, especially given that his life was dedicated to understanding information and how our minds work.
It makes you think, Like, even with all our technological advancements, we're still fragile.
And it raises a lot of tough questions about how we're handling this flood of information.
Right. Shannon dreamed of faster, more efficient communication, and we've achieved that. But are we using this power wisely?
That's the million-dollar question. We're bombarded with information, but are we really more knowledgeable, more wise?
Are we just drowning in data?
And how do we sift through all the noise and figure out what's true, what's important? We're dealing with misinformation, filter bubbles, and all sorts of new challenges that Shannon probably couldn't have imagined.
It feels like we need more than just efficiency at this point.
I think so too. We need critical thinking, discernment, a commitment to using information ethically and responsibly.
Those are qualities that technology alone can't provide.
Exactly. Shannon gave us the keys to this amazing world of information, but it's up to us to use those keys wisely.
So to everyone listening, as we finish up this deep dive into Claude Shannon's world, I hope you'll think about his legacy. Not just the incredible potential he unlocks, but also the responsibility that comes with it. His work changed the world, and it's up to all of us to continue shaping that world in a positive direction. Thanks for joining us.